Hello everyone. Let's do a quick recap of sorting concept. We have covered two different ways of sorting a list of items using sort method call and sorted function call. What is the difference between the both? Recall that the sort method call rearranges the items in the original list object instance, whereas the sorted function call creates a brand new list object instance to store the rearranged items. Recall that we have covered various examples of sort method to sort a list containing primitive objects as items. Recall that when you sort a list of integers or floating point values, you'll be rearranging the numbers in increasing or ascending order. When you sort a list of strings, you'll be rearranging the items in alphanumeric ordering. If you sort a list of Boolean values, you'll be placing the falses before the trues. Of course, we cannot sort a list which contains both a string and an integer as items because that does not make any sense. In today's lecture, we'll be covering advanced examples for sorting. You're going to need the learning from this particular lecture video for future project questions which are about sorting. So please come back to this lecture video if you want to review advanced sorting examples. What if we want to sort a list containing other data structure object instances as items instead of just being able to sort a list containing primitive objects as items? In this example, I have a list object instance which contains three tuple object instances as items. I'm storing a reference to the list object instance inside the variable names. Each tuple object instance is storing the first name and last name of a person. If I invoke the sort method call on the variable names, that's going to sort the tuples within the list based on first element, which is first name here. So we'll end up with Alice Clark first, Bob Adams second, Catherine Baker last. What if we want to sort by last name, which is more common than sorting by first name? What if we want to sort by length of a particular name? How can we solve these two questions? If we were to come up with our own sorting function, we'll have to deal with the complications of corner cases. Sorting technique by itself is an extremely complex programming concept. People do research on how to come up with best sorting techniques. So we are not going to come up with our own sorting function. Instead, we are going to leverage a named keyword argument which is included as part of the definition for sort method and sorted function. The name of the parameter is going to be key, which is a very bad name. This parameter name key has nothing to do with dictionary keys. We are going to pass as argument the function object reference, which is going to indicate to the sort method and the sorted function as to which particular field within the data structure object instance is significant for the sorting. Let's go through an example here. Let's go through the definition of extract function. The extract function is going to take as argument a single tuple object instance which is part of one item within the original list of items here. The parameter name here is name underscore tuple. Please don't get confused this parameter name with name tuple. This has nothing to do with that. This is just a variable name which has the name as name underscore tuple here. It is very important that you understand that the extract function here is going to only deal with one of the items within the original list of items. Why is that significant? That's because the sort method or the sorted function is going to be the one which applies the extract function to each item within the original list of items. So within this particular extract function, you're only going to worry about one of the items within the original list of items. What are we returning from the extract function? We are returning the item at index position 1 as part of the variable name underscore tuple. So that's going to be the last name value here. Then I'm invoking the sort method on names variable by passing the argument as extract function object reference into the parameter key. That's going to enable us to sort the list with the order as Bob Adams first, Catherine Baker second, and Alice Clark last. Observe that we are now able to sort the list of tuple object instances based on the last names here. Let's modify this example slightly so that we can sort the list of tuple object instances using length of the first name. From the extract function, I'm simply going to return len of name underscore tuple of 0. That's going to enable us to sort the values as Bob Adams first, Alice Clark next, and Catherine Baker last. Let me switch over to the Jupyter Notebook session and we are going to go through example 3. Instead of using list of tuples as my example, which was already covered in the slide deck, I'm going to use list of dictionaries to show you the use case for sorted function. I have a variable hurricanes here, which is storing a list of dictionaries. Each of the dictionaries within the list represent hurricane information, which includes details of name of the hurricane, year during which the hurricane was formed, and speed of the hurricane here. Let's go through basic indexing here. Hurricanes of 0 is going to retrieve the details for hurricane A here, which is going to be the dictionary. Hurricanes of 1 is going to retrieve the dictionary for hurricane B. What do you think will happen if we say hurricanes of 0 less than hurricanes of 1? We are going to get type error less than not supported between instances of dict and dict. What exactly this type error is telling is Python does not have a meaningful way of comparing the dictionary object instance at index position 0 with the dictionary object instance at index position 1. That's because each of those dictionaries have various key value pairs. Python is not able to determine which one of those keys is significant for the for the comparison here. Similarly, if we were to call the sorted function and pass hurricanes as argument, you're going to get the exact same type error because sorting requires you to apply the less than and greater than comparison operators between the items as part of the original list of items. So let's define the get underscore year function. Recall that the function which is supposed to be the argument for the parameter key needs to deal with one of the list items. So for the get underscore year function, we are going to include the parameter as one hurricane. The get underscore year function is going to be pretty straightforward. We are simply going to look up the value corresponding to the key year within the parameter variable hurricane here. So let me go ahead and execute this function definition. I'm now going to call the sorted function by passing hurricanes as the first argument. The second argument is going to be my named keyword argument. Parameter name is key. Then I'll have to mention equal to. Then I'll have to type in get underscore year here. Let's run this function call. Now observe that we are able to sort the list of dictionaries here. We are getting Hurricane B first because the year is 1980, then Hurricane C because year is 1990. Finally, we are getting Hurricane A because the year is 2000. How many times did you think that we called the get underscore year function here? That's a tricky question. That's because we did not directly invoke the get underscore year function. Let me add a debug print statement within the get underscore year function here to display the hurricane details. So I'm simply going to say print of string debug comma hurricane here. Let's execute the function definition for get underscore year again, and I'm going to call the sorted function one more time. Observe that we got the debug print function call output 3 times for each of the hurricanes. That's because the sorted function is going to invoke the get underscore year function because you're passing that function object as argument to the key parameter here, and it is going to invoke that particular function every time for every item within the original list of dictionaries which is given by hurricanes here. So you will not be explicitly invoking the function which provides details to the sorted function or sort method call as to which particular field is significant for the sorting. By defining the get underscore year function, we are letting sorted function know that the year key is the one which is significant for doing the sorting here. Let's change that slightly. We're going to define a get underscore speed function, which is once again going to take only one hurricane dictionary as argument, and it is going to return the speed value from that particular hurricane dictionary. So I'm simply going to do the lookup of hurricane of speed here. We are going to use an updated list of dictionary examples. Notice that in Hurricane C, I have purposefully removed the key value pair with the key as speed. Let's call the sorted function call and pass hurricanes as the first argument, and the second argument is going to be the named keyword argument, which is going to be parameter key and the argument get underscore speed. Observe that we are getting key error for speed. Clearly, the third dictionary here does not have a defined key speed. So how can we handle this? Recall that we can use the get method as part of the dictionary to return a default value if a particular key does not exist. The syntax for that is get method call the key that we are trying to look up and the default value, which I'm configuring as 0 in this particular case. This is a good way of dealing with non-existing entries for the speed for a particular hurricane. Practically, datasets might not have all the entries. So let me execute this function definition for get underscore speed again. Observe that now we are able to get through the sorted function. We are going to place the hurricane C as the first item within the sorted list of dictionaries here. Why is that? Recall that we are setting 0 as the default speed. 0 comes before 100, so that's why you're placing hurricane C first. How do you change your sorting to take into account reverse or descending sorting? Let me show you two ways for that. The first way is to configure named keyword argument for the parameter reverse, and you're going to pass the argument as boolean value true. If I execute this cell again, now notice that we are getting reverse or descending order sorting here. This is one way for you to handle that. Another way would be for you to apply transformation within your get underscore speed function. I can just negate the speed value. That's going to again enable us to come up with descending order sorting. Observe that we are still seeing the descending order sorting with the negation here. You can apply any kind of transformations within the function that you're defining for the sorting here. Let's go through this one final example here, which is going to enable us to update the sorting of this list of strings here. Recall that when you invoke the sorted function, you're going to sort the uppercase strings before the lowercase. This is the behavior in all the programming languages. Let's say that we want to perform a case insensitive sort here. How can you do that? You can define the named keyword argument for the parameter key as str.upper method function reference, and that's going to enable you to get rid of the cases while considering this particular sorting, and you're going to sort the list of strings immaterial of the strings case here. I'll wrap up this video here. In the next video, I'm going to briefly introduce you to the concept of lambda.